Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. My guest is Robert Hauge, President of Space Logistics, a wholly owned subsidiary of Northrop Grumman. The company provides cooperative space logistics and in-orbit satellite servicing to geosynchronous satellite operators using a fleet of commercial servicing vehicles. And Rob, thanks for joining us on the program today.
Thank you. You called it a fleet. Right now it's two. We're looking forward to having a whole lot more, but we've got two, so that starts.
I count a fleet as more than one, so I think we're all good there. But let's start with your background, and then we'll get into some of these nuts and bolts. Tell us a little bit about yourself.
Sure. So I spent almost 30 years on the U.S. government side. I spent a lot of that time working for the National Reconnaissance Office, and the last job I had, which I can now say, is I was the commander of Aerospace Data Facility East, which is a ground station for the NRO in the Washington, D.C. area. So when I was retiring from the government, I had heard what we're going to talk quite a bit more about, I think, in this podcast, the mission extension vehicle. And when I saw the ability to extend satellites on orbit, I realized, there's a lot of applications to the U.S. government side as well. And not surprisingly, that was a good match for me coming over to work for Northrop. So I came on board in August, and then in January was asked to take over as president for all of space logistics. It's been a huge responsibility, but also an absolute blast. And so I'm glad to be here. Thank you, Tom.
Well, let's talk about those two, hopefully more soon, commercial servicing vehicles, and what benefits do they bring? You said you saw a lot of potential uses for them, not only in the commercial sector, but also in the government sector. So what do they do?
Well, so what I think is important is a lot of people talk about in-space servicing. That's kind of the term of reference the White House is now calling it that, as opposed to on-orbit servicing, because in space can mean anything, not just Earth orbits. This, for us, when you talk about the market, there really is only us, Space Logistics, up there in orbit, providing that in-space servicing capability today. But what I want to foot stomp is that effort really started about 10 years ago when Northrop Grumman recognized, hey, there's the ability to go extend these satellites at GEO. So let me give a little context. Right now, there's about 400 GEO satellites in orbit today. So those are the ones that are 22,000 miles away. They've got that 24-hour period. It's a prime real estate for supporting space telecommunications. But about 15 of those satellites a year, between 10 and 20, about 15 a year, reach their end of life simply because they run out of fuel.
Right.
And so the idea was, could we go and extend those satellites? Well, how do you do that for a satellite that's unprepared? Well, it turns out about 80% of the satellites in GEO get there from going from a geosynchronous transfer orbit, GTO, and they raise their orbit out to GTO with a liquid apogee engine, which is about this big and about this big around. And so that's actually how we dock. And that's kind of our special sauce, is what we call our capture mechanism, that we dock with that spacecraft. We don't, and I want to make sure it's clear to your viewers and listeners, we don't actually refuel. We're more like, and I struggle because as an engineer, it's an oversimplification, but we're kind of like a jetpack for that satellite. And so our goal is to go extend the life of those satellites on orbit. Now, to be able to do that, we also needed a very sophisticated RPOD system, rendezvous, proximity operations, and docking. And so we've done that now based on what we do with our Cygnus resupply vehicle to the space station, taking that technology on a mission extension vehicle 1, and now on to mission extension vehicle number 2. Both of those are supporting 2 Intelsat satellites. What's significant about that is we actually just crossed the first anniversary this April with mission extension vehicle 2. When it docked with the Intelsat satellite, in particular 1002, that satellite remained in mission. They had 18 million customers on that satellite.
Wow. And
we docked so gently, there was no disruption. And for your engineers that are listening or watching, thinking about that lever arm aspect, being able to do that, that is demonstrating the level of sophistication that we've gone to, which obviously you can imagine that the US government and others, our allies, would have systems that they can't take out of mission. So that was our goal, was to demonstrate that we could take it all the way to that point. And now where we're heading in the future, this mission extension vehicle is, for most satellites, more than what they need. It's about the size of a school bus. It's about the size of a minivan. And it takes over the complete operation of that spacecraft. Well, what I mentioned was all they really need is essentially delta V, the augmented propulsion. And so what we're doing with our next generation system is called our mission robotic vehicle, which we're going to launch in 2024. And we're going to be installing with that what we call mission extension pods. And these are about the size of a dishwasher, and they're only electric propulsion. And so we'll use that same docking technique and install that on the spacecraft, and they'll get about 6 years of life extension out of that. So right now we've selected our rocket, which is going to be SpaceX. We have got our first customer on board. We've got a number of others that are lined up that I can't announce yet, but we got our first customer with Optus. That's the largest satellite telecommunication provider in Australia, very well respected company. For our first mission extension pod, and we're going to launch in 2024. So that's where we're heading. Everything today is, what can we do for the satellites that are on orbit today, particularly at GEO, that have unprepared interfaces?
Now you said something that I found kind of interesting. You've got two vehicles right now. This is a situation where each of your spacecraft will go and dock with a satellite, and then it stays with that satellite. It doesn't push it back into its correct orbit and then move on to the next satellite.
That's a good question. So with the satellites at GEO, they're mainly dealing with what's called north-south inclination. So every year they go up about 1/8 of a degree. And eventually, as that satellite starts to move out of its box, it's basically tracing out essentially a figure 8 in space if you're watching it from the Earth. If it moves far enough outside of its box, it's the reason DirecTV works. They install this antenna on your house with a fixed azimuth and elevation, and they're counting on DirecTV to hold its node. And so as these satellites start to run low on fuel, they have to maintain that orbital box. Now, some have the ability to track some of their users, but like DirecTV, for example, wouldn't. So they need to be able to maintain that. So for us, it's not sufficient to do what we call a pull down, an inclination pull down, where we pull them back down to 0. We could do that for some satellites. Most of these satellites have a very tight orbital box, which means you really need to be there every day. And that's why we need really two different classes. The mission extension vehicle got us going. That's based on our GeoStar commercial product line from Northrop Grumman. But the mission extension pod enables us to get to a much lower price point, so that it's competitive for the satellite telecommunications operators we're working with to say it's worth extending that satellite.
How does this, and you touched on this a little bit earlier on in your comments, but how are we comparing this to the so-called orbital gas stations that we're hearing a lot about from some companies?
So I've got a lot of thoughts on that. Right now, it's important to understand, especially if we focus on GEO, because that's really where our market is right now. We eventually will move to other regimes, but by far the greatest, where we think the greatest business is in the GEO market. There are no satellites that have prepared interfaces for refueling.
Right.
So that's why we went down the route with the MEP, the mission extension pod, the MEV, essentially as jetpacks. We don't refuel. We essentially are that jetpack for them. But clearly the next step is to move down the realm of refueling. In fact, some of the customers, the companies that are moving in this area, not only are we engaged with them, but we've actually been investing as Northrop Grumman as a company in them. And this is important because one of the things we try to communicate is, Pam Melroy, I think, said it well, the deputy director of NASA. She said it this past fall, is this idea of collaborate to compete. And I think that's really what it comes down to. So while space logistics is the first in the world to be able to offer these capabilities, clearly we'd like to get to prepared interfaces, and we want to get there as quick as possible, which means we want to have non-proprietary interfaces. We want to have open standards. In fact, We're a member, along with a number of other companies, in an organization that's known as CONFERS, which stands for the Consortium for the Execution of Rendezvous and Servicing Operations. And that group is trying to set standards for the entire industry. Again, if we can get to that point, our goal is not to make money on the interface. Our goal is to get that market out there where satellite telecommunications operators say, you know, it makes sense based on what I see space logistics doing, but also the ability to refuel in the future. It makes sense for me to plan that interface onto that spacecraft, meaning good business sense for them.
So what you're looking at is eventually satellites will be built with the capability to dock with any one of a number of it's the Shell station, or it's the BP station, or whatever station it is that they happen to be nearest, to be able to refuel their satellites.
Tom, that's true. Although I just came off an hour-long phone call with our engineers within the company, that while that an analogy at a high level holds, trying to do that in space, in the vacuum of space, where let's say you are passing hydrazine and you spill fuel, well, that fuel doesn't just stay around your spacecraft. It can go on to optics, which means it can actually affect a star tracker or a sun sensor. So you've got to make sure that works. But even before you get there, the ability to dock these two, you know, it's one thing to think about trying to transfer fuel as two hockey skaters in a rink. But remember, this is 3D. And so you've got this heavy spacecraft that may or may not, it might be a shuttle with a smaller amount of fuel, or a large, like your analogy, the tanker truck. And then you've got another satellite, and that might be in mission. So there really is a whole lot of detail that's going on behind the scenes to be able to make that work. Again, our point is, if we can get the satellite industry comfortable that we can extend what they've got, then that will make them more willing to say, okay, well, if we put that prepared interface, you'd use the same kind of techniques. Yes, the same kind of techniques to dock with you to refuel in the future.
Now, SpaceX has shown the benefit and increasingly the necessity of reusable space hardware. So are the solutions you're looking for future satellites, or can they be adapted to satellites that are currently in orbit?
So what I love about space logistics is we really are all about making space sustainable. I've been thinking about, there's the slogan on Earth that we tend to use, which is reduce, reuse, and recycle. And if I think about it from a simple perspective, that's really what we're trying to do with space logistics, is to take that to space. And so let me give a couple examples. So reduce. Today, we can do that. We can reduce the need for building new satellites. We can do that with our mission extension vehicle and our mission extension pods to be those jetpacks to extend the life of what we've already got. But what's coming in the future is the idea of reusing. In other words, reusing parts from old ones. So if we're able to have the ability to not just a refueling interface, but also a power and data interface, think about it as a very, very fancy USB port in space. Now you can think about this idea of using the mission robotic vehicle to be able to install parts on that spacecraft. Either on the bus side, you've got a rate sensor that's failing, and you plug in a new one into that same bus on the spacecraft. I don't mean bus physically, I mean bus is in the data transport layer on that spacecraft, or upgrading components to the payload on that spacecraft. So you're now upgrading and reusing that spacecraft bus, the main structure, versus throwing away those satellites. And in particular, where we see this heading as a company is really the transition from a free-flying satellite on a dedicated rocket for a one-way mission to do a one-for-one replacement for what's there, is to think about this idea of boxes going up as ride shares. It's not even a free-flying satellite anymore. It's going to wait. And the point being is that drives the cost way down, and you would use the mission robotic vehicle, which has got all the capabilities on board with its robotic arms to very gracefully grasp that box, take it over to the spacecraft, and again, very gracefully plug that into the spacecraft. And then the last part on the horizon, so I talked about reduce, I talked about reuse, and really further out where we'd like to go, this is out there, but recycling, the idea of how do we recycle what's already there to build new ones? There are hundreds of satellites in the geo belt that are defunct that we can get access today, and hundreds more out in the graveyard orbit, about 300 kilometers above geo. If we could take those spacecraft and take parts off of those and start actually breaking them down into their constituent elements, we can start thinking about building things that we could never build on Earth. In other words, I don't necessarily need pure aluminum, but I need metal. So even if I can mix those together, and even if I had voids and so forth, again, you're in zero G. So you don't have to build the same structure you do on Earth, which has to survive that controlled explosion called a rocket launch. You can actually build that on orbit. So we're envisioning the idea of building large booms, large antennas. And then one of the interesting parts is there's the ability not just to use krypton or xenon for electric propulsion, but as some of your listeners may be aware, actually do metal propulsion, where think about it like a very, very fancy candle, where you've got the wick in the middle and you've got the metal, which is basically going to be with high energy burned off. And why that's important is the idea of not just building structures, but if you could do that, you actually have the ability to now start essentially making fuel in orbit. If you're already out there at 36,000 kilometers away from the Earth, you've got the ability to think about not just changing inclination, but going all the way out to XGEO, all the way out to cislunar and beyond with these fuels. And so that's further out there, but for us, it really comes down to that reuse, reduce, reuse, and then eventually recycle what we've got on orbit.
I'm talking with Robert Hauge, President of Space Logistics, on the Ex Terra Podcast. Take a moment right now to click on subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. So Rob, it seems like you're seeing space debris as kind of a big issue affecting satellite servicing, the satellite servicing industry. Is that the case? Is part of what the big problem is the fact that there's so much junk out there?
So it's definitely an issue for LEO. Obviously, it's an important issue in every orbital regime, and the challenge is at LEO. But as far as servicing, and particularly where we're starting out at GEO, we're fortunate that while that orbit is unique, being 36,000 kilometers away, that orbit has also been treasured by countries as well as companies, and there's an entire industry that's in place to make sure that that's regulated, meaning that when those satellites reach their end of life and before they get there, this is the key part, before they get there, they leave enough fuel to be able to super sync themselves. They leave enough fuel to be able to take themselves out to the graveyard orbit, which is plus 300. So from my standpoint, the debris is not necessarily the challenge. The big issue that we need to be thinking about is the fact that for the past 60 years, we built satellites the same way. We build it, then we bake it, then we shake it, then we shock it, then we radiate it with RF energy, then we blast it with the acoustic noise of a rocket with the acoustics test, and then we fold this thing like an origami structure onto that rocket, into that rocket fairing, and then we send it on that one-way trip until it runs out of fuel. And then we build another one to go in its place. And as I mentioned, we've got about 15 of those a year that are reaching their end of life. And really what we're trying to do, and the challenge is to try and change that, to be able to extend what we've already got on orbit. And here's some of the advantages. If you can extend what you've already got on orbit, and you can imagine if you've already essentially paid for that spacecraft now, and it's still functional and fuel is the only limiting factor, for a fraction of the cost, you can extend what you've got. While you're extending that, that also enables you to defer those capital expenses on that next spacecraft. There's a lot of interest in high throughput satellites and software defined payloads and so forth. Going to those new designs means additional costs. And we're giving these telecommunications operators the ability to say, well, you can extend what you've got and essentially save those resources and put them towards a higher fidelity payload in the future. And all of this is really about what the theme I keep coming back to is reducing the need for new satellites. Now, even to that point, with our mission extension pods and with our mission extension vehicles, we can take those satellites to graveyard at the end of their mission to essentially keep that belt clear. But if there is a satellite that runs into a difficulty with these robotic arms, we're essentially able to safely work with them and grasp a spacecraft again that's not prepared and take that satellite. We call it active debris removal. Others in the community call it ADR as well, to be able to keep that belt clean.
But it occurs to me that the speed with which technology changes these days, yeah, it's okay if you can go and you can keep the satellite on orbit, but how practical is that in the reuse and reuse realm if the technology that's on board has become obsolete?
So I'd say a couple things about that, and you're absolutely right. And it's in fact it's a really good question because a lot of what's talked about in the commercial satellite telecommunications industry is the dollars per transponder and how those are continuing to go down. So you kind of have two different approaches. There's a lot of uncertainty as to what the market's going to look like in the future. So one approach would be, therefore, I should go buy all these new satellites, and yet the cost per transponder is going down and down and down. So I'm now going to a market that's got even more and more transponders. And our point is coming in to say, well, you kind of have a win-win scenario where you can take what you've already got, essentially you've already paid for that satellite, and to be able to extend that further and then put that money towards a true upgrade where you can have a software redefinable payload in the future. The other thing I would say, and this is an important distinction on the US government side, and let's take an example like OPIR, overhead persistent infrared capability. So the USS satellites that have that, clearly it's for missile warning. There's no commercial market for that. So if a satellite is 10 years old and it's providing OPIR and it's still providing useful data, do you keep it? Yes. 20 years old? Yes. What if it's longer than 20 years old? Well, if from the government standpoint, if the payload is still working, they're going to want to keep it. In fact, General Gutlein, Lieutenant General Gutlein, who is the commander of the Space Systems Center in Los Angeles for the U.S. Space Force, he was actually just talking in Air Force magazine this past week. And one of the things I like the phrasing that he's using, and what he's talking about is the idea of let's exploit what we have, meaning hang on to it, buy what we can, but only build what they must. And in particular, he's basically seeing the future is, in his words, not divesting ourselves of our legacy assets. So to your point, Tom, for the commercial market, there is a point where the utility starts to fall. And that's exactly where our mission extension pod comes in. I mentioned about the mission extension vehicle, again, size of a minivan, 15 years of life. Mission extension pod is much less expensive, and it's designed to provide 6 years of life, because that's kind of where we've looked at the market. At that point, the commercial folks are probably going to want to go on to another system, not necessarily for the US government. If they want to hang on to everything they've got and they're at the end of life with respect to fuel, we can come along and continue to upgrade with pods going forward. And that's why there's interest in what we're doing.
As we're talking about the government, the Biden administration recently announced that the US has committed to a ban on destructive ASAT tests and is asking other nations to join in that effort. How important is such a declaration for the satellite industry?
So I'd say a couple of things. Anything that causes debris is not good. We definitely don't want to be able to have that. If I took a look at just what we've got in GEO, there's data that says there's about 360 defunct satellites in GEO. Okay, that's not the GEO graveyard orbit. That's GEO. And so the difference, though, unlike with low Earth orbit, when you've got the potential for collisions, and as a ground station commander, I lived with this on a daily basis because we had to keep our satellites in mission, and at times we had to do what's called a COLA, collision avoidance maneuver, to be able to obviously avoid that piece of debris. It's less of an issue at GEO because we know where these things are. They tend to be in one location. This is the key part, Tom, in one piece. Right. So when you've got a satellite at GEO, we can tug that out to super sync. But if an adversary was to do an ASAT test at GEO that breaks that satellite up into pieces, that would make a much bigger challenge for us. So our robotic arms are great for being able to go reduce that clutter and remove that junk, defunct satellites, upper stage motors, and so forth. But if we had debris, not only is it an issue for other satellites, but trying to go pick up all those pieces are going to continue to stay in that region for many, many, many years to come. And so our intention is all the more reason we want to keep only in the GEO belt what needs to actually be there.
And Rob, you're on the list to be one of the featured speakers at Space Tech Expo out in Long Beach in May. Can you give us maybe a little bit of a preview of what you're going to be talking about?
Sure. So I'll be part of a panel, and we're going to be looking at the ways that we can establish a resilient space logistics infrastructure. And one of the themes will be, how does robotics play in servicing and in-space assembly missions? I'll be talking more about our mission extension vehicle, the ones that we've got on orbit, where we're going with our mission robotic vehicles. But what I'm hoping to also share is much what I'm sharing with you, is this idea of making space sustainable through this idea of reducing the number of spacecrafts we've got, reusing the parts on these older systems, and then recycling what's left to be able to build new structures, new spacecraft, new systems that we haven't even thought of yet. When I say haven't even thought of yet, that's a key part, that with our mission robotic vehicle, while it installs these mission extension pods, we have designed this to be a multi-mission spacecraft. Clearly, you can imagine we could do inspections, but also the ability to do repair, a solar array that's stuck, to be able to release that, to be able to reposition, take a satellite out to super sync. But again, this idea of where we're going with in-space assembly, there's lots of different directions that can go. But at the end of the day, you can have all the greatest ideas, but our position is you're going to want a system in space that is very capable to be able to be reprogrammed to do a lot of different missions, essentially via telerobotics. And that's what that mission robotic vehicle is going to give us, not just the extension, mission extension pods for life extension, but all these other missions, to include ones we haven't even thought of yet.
Something that occurs to me, and I've got a couple of minutes here. When I think about the advances in electric vehicles here on Earth, and then you take the advancements in the conversion of solar energy to electricity, and the way Hall thrusters are now coming online as more of a useful way of propelling spacecraft, is there a point where we're going to get away completely from this idea of chemical reactions to power our satellites? The rockets, I'm sure we're going to have those big booms to get them off the ground. But once they're up there, can they be all electric?
That is a really good question. I'm smiling because these are some of the same discussions that I have with the Space Force. And I'd say a couple things. First of all, the price of xenon, I don't know what the going rate is in dollars per kilogram right now, but it is going through the roof. And a lot of that has to do with what's going on in Ukraine now. A lot of it has to do with COVID-19 impacts, with supply chain and so forth. So there's a reason we tend to use xenon for electric propulsion. Obviously, it's neutral. And when we're ionizing those particles coming out, we know it's not going to cause any degradation to any of the sensors, as I was mentioning about with hydrogen if it leaks on orbit. But we as a company, and we're not the only ones, we're also looking at krypton. Now, krypton has other challenges with it, but mainly it's cheaper and it tends to decay the HCT, the Hall current thrusters. So there's challenge with that. The point is, absolutely, we see a market for going into electric. In fact, what we've done with our mission extension vehicle, because we were trying to get down to that smallest price point, we are actually designing our own electric propulsion system. And that HCT, we just tested a couple weeks ago. It's based on a design that was developed at NASA for a very low power, compact, but reliable electric propulsion system. And we're designing everything else to go with it. And we're envisioning that's not just for the use for space logistics, for doing these mission extension pods, but to kind of where you're heading is, if you want to go cislunar and beyond, it's all about ISP. I mean, you want the highest efficiency you can get. However, the other side of it is there's a reason why, and I'm a retired Air Force officer. This was before the Space Force came along, or I probably would have been Space Force. But there's a reason that the Air Force, their aircraft don't just have what they call mill thrust. Mm-hmm. The fighters have afterburner. Well, what is afterburner? That says when I need to get the hell out of Dodge, or I have to get from point A to point B as quickly as possible, I need to be able to do that. And so I do believe we're going to see, for example, the Space Force and others, still the need for chemical propulsion. You know, I kind of joke, you know, you've got two snails trying to race across space. Well, that may be the most efficient, but I believe the Space Force is going to want to have chemical propulsion in the future in that mix as well, when they need to go deal with the threat or to be able to protect one of our satellites.
Rob, this entire podcast has kind of been on this last question, but maybe just kind of encapsulate it a little bit and look out, if you will, over the next 10 to 15 years in space commerce and tell us what you see.
So clearly what we're trying to do as a company is jumpstart the market with extending the satellites that have unprepared interfaces. Clearly, if we can get into the realm of refueling. I'll be upfront with you, refueling is a challenge. It's a challenge because let's assume right now, today, the entire industry agrees to what that refueling interface needs to be. And let's say it works, it's ubiquitous, it works on all satellites. So we agree to do that. Well, now you're a satellite telecommunications operator. You agree to put that on your satellite. It's going to take you 3 years, likely maybe closer to 4 or 5 years to build that satellite and to be able to put that satellite on orbit. Now, these geosatellites in particular are designed to last on the order of 15 years. Mm-hmm. So you start adding that up and saying, when do I get the advantage of refueling? Which, flipping that around, where is the market for people to build refuelers? And you're really looking 15 to 20 years from now is when they're going to be ready to take advantage of them. So for us as a company, we're going with what we believe is the most viable business case for us, which is extending what we've already got. But we absolutely want to go into the realm of being able to have refueling ports. In fact, Northrop Grumman is a company, we are already funded to do some work in this area to design refueling ports. And where we're heading is when we develop that interface, we're going to make it available to all. Again, back to this theme of we're trying to collaborate to compete, as Pam Melroy said. We want to make this market as broad as possible. And of course, Space Logistics wants to be there to compete. So going further, that's the power and data ports, the ability to have these on-orbit attachable capabilities, essentially plugging in a box to upgrade a satellite. Even further on the in-space manufacturing side is the idea of essentially building a large structure. I like the term I've heard NASA use is hoteling, that you would essentially have a robotic vehicle or robotic arms that are on some structure, and you launch spacecraft, or now boxes again up there, that get essentially plugged into this large space structure to be able to hotel and get access to power and data and have the whole structure essentially do the station keeping, where you can just keep doing your risk reduction on the payload piece, the tech piece. While that's all cool, the hardest part and what really needs to be done, and we're doing it as Space Logistics, we're absolutely participating, as standards. And in order to do that, we are going to have to work together. And so I want to make a pitch for confers, for folks to engage that group. There are examples in history, and I use the example, I used to be a program manager at DARPA, TCP/IP, what we use for the internet. The government set that standard and everyone followed. Well, there's a lot of other examples where the government set a standard and industry said, we're still going to go another way. And so again, back to this collaborate to compete. We want to get people together to at least agree to how do we want to operate in space. And maybe there's multiple companies that are building interface standards, but the key thing is they're all standards, so they'd be cross-compatible with one another. We've got a long way to go to get there.
Rob, that's all the time we have. I really appreciate you joining me today. It's been an interesting conversation.
Well, thank you, Tom. Appreciate the time.
Robert Hauge is president of Northrop Grumman subsidiary Space Logistics. And that is going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.